Good morning students. Today in this video I am going to discuss the chapter 4 quadratic equations concepts of this chapter class 10th NCERT. First let's see the intro of this chapter, introduction, quadratic polynomial definition. So how can we define a quadratic polynomial? Polynomial of the form ax square plus bx plus c is equal to, if we equate this to 0, we get the quadratic equation. So hence polynomial of the form ax square plus bx plus c, wherein a is not equal to 0, this form of the polynomial is called as the quadratic polynomial. When we equate this polynomial to 0, we get the quadratic equation. So next, how do we define quadratic equations? So definition of quadratic equation would be like this. A quadratic equation in the variable x is an equation of the form ax square plus bx plus c equal to 0, where a, b, c are real numbers and a is not equal to 0. For example, if we say that 2x square plus x minus 300 equal to 0, or 1 minus x square plus 300 equal to 0, both of these are examples of quadratic equations. Hence, we can say that any equation of the form p of x, where p of x is a polynomial of a degree 2, is a quadratic equation. So hence ax square plus bx plus c equal to 0, where a is not equal to 0, is called as the standard form of the quadratic equation. Next is the solutions of quadratic equations by factorization. So how do we find solutions of a quadratic equations by factorization? Let's discuss. So in general, we can say that let's say a real number is alpha is called as a root of the quadratic equation when ax square plus bx plus c equal to 0, where a is not equal to 0 if a, that is alpha square, a alpha square plus b alpha plus c equal to 0, that is x is equal to alpha. That is, we also say that x is equal to alpha is a solution of the quadratic equation, or we can say that alpha satisfies the quadratic equation. So here there is a note, two notes given. First note is that the zeros of the quadratic polynomial, that is ax square plus bx plus c, this form quadratic polynomial, and the roots of the quadratic polynomial are not different but the same. Actually, roots and zeros are two different names. We use the word zeros of the quadratic polynomial when we mention the equation in the form of polynomials, whereas we say the same values which satisfies the polynomial, when we write it as equation, we say it as roots. That's it. The second note is that if we can factorize ax square plus bx plus c, wherein a is not equal to 0, into product of two linear factors, then the roots of the quadratic equations ax square plus bx plus c equal to 0 can be found by equating each factor to 0. For example, if we give values to a, b and c, say 5, 6 and 7, 5 to a, 6 to b and 7 to c. If we do so, we can factorize each term. So 5x square equals 0, then x square equal to 0 by 5. Like that, we can assign values to each values and we can easily factorize. Next topic is nature of roots. The equation ax square plus bx plus c equal to 0. This equation is given by x, wherein x is equal to minus b plus or minus root of b square minus 4ac divided by 2a. And this formula is called as quadratic formula. Now the under root value, that is b square minus 4ac, this value is equal to 0, then the x value becomes minus b by 2a plus or minus 0. That is, x value will be equal to minus b by 2a or minus b by 2a itself. So hence the roots of the equation ax square plus bx plus c is equal to 0. The roots, both the roots, two roots would be there. Both the roots would be minus b by 2a. Hence, therefore, we can say that there are two equal roots. That is, two equal and real roots for the equation, for the quadratic equation ax square plus bx plus c equals 0. If we say that in first condition we equated the discriminant value b square minus 4ac to 0, if the same value is greater than 0, we get two distinct roots. Say minus b by 2a plus root of b square minus 4ac divided by 2a and minus b by 2a minus root of b square minus 4ac by 2a. We get two distinct values, right? And next, if the same value is less than 0, that is, if b square minus 4ac is less than 0, then there is no real number whose square value is b square minus 4ac. So there are three conditions for the nature of roots. First is discriminant value, that is d is equal to b square minus 4ac would be equal to 0, or it would be greater than 0, or it would be less than 0. So therefore we can say that there are no real roots for the given quadratic equation in this case, as I said already, if it is less than 0. Since b square minus 4ac determines whether the quadratic equation, that is of the form ax square plus bx plus c equal to 0, has real roots or not. Hence we can say that, as I already said, b square minus 4ac is nothing but is called as the discriminant of the quadratic equation. So the quadratic equation ax square plus bx plus c is equal to has three conditions. As I said before, it is summarized as two distinct real roots if b square minus 4ac is greater than 0, and it would have two equal real roots if b square minus 4ac is equal to 0, and there would be no real roots for the equation, for the quadratic formula, if b square minus 4ac is less than 0. And therefore that's all for the concepts of this chapter. I hope you guys really understood the concept. In the next video, the further videos, I would be uploading the rest part of the videos. Thank you.